Hey everybody, welcome to Module 6, which is all about the constant of proportionality. Learning targets, you will be able to, 1, find the constant of proportionality from information given in a table, graph, or word problem. And number 2, you'll be able to write an equation of the form y equals kx to represent a proportional relationship. So where we've been, we know that when two ratios have the same rate per one, which is unit rate, they are equivalent ratios. We also understand that if the ratios between two corresponding quantities are always equivalent, then we say they are proportional. Here's the table that you did the discussion post on last week. So you're noticing and wonderings. And this is just it's an example of a proportional relationship. Many of you pointed out that you noticed for every one case, there would be 12 rolls of paper towels, and you noticed patterns within the table, which is fantastic. And you wondered, some of you, why the numbers skipped in the table. And I just want to remind you that ratio tables can do that. We don't have to include every single equivalent rate, because once we get the gist or the unit rate of something, then we have enough information to be able to answer questions about it. So what on earth is this constant of proportionality idea? Well, first, it's the constant value of the ratio of two proportional quantities, x and y. That sounds really fancy, but it's basically another term for the unit rate. So when we compare the x and the y, those two different things we're talking about, the constant of proportionality is just that relationship between them, the unit rate. Down here, it says it's represented by the variable k in the equation y equals kx. And that equation will make a little bit more sense later on. But that k is where we plug in what the unit rate is, or again, it's called the constant of proportionality. And how do we calculate it? Well, just like we calculate the unit rate, by dividing the y by the x. All about looking for patterns still. So let's take a look here. Let's get kind of warmed up to this idea. Here we have feet being compared to how many inches are in a foot. And this last column is the y divided by x, or again, this is that k, or the constant. So what is the constant of proportionality here? Y divided by x would be 12 is the y, divided by its x over 1, that's 12. 24 divided by 2 equals 12. What do you notice? 36 divided by 3 is 12. This is a proportional relationship because the unit rate is the same throughout. The constant is 12, or again, the unit rate. So how do you know that the number of feet is proportional to the number of inches? Well, the unit rate, or the constant, is the same. And they're all equivalent rates. So using x, the number of feet, how do you find y, the number of inches? Well, to find y, we have to multiply the x value by 12. That's how we go from one column to the other. We go backwards, we use division, right? It's all about those multiplication and division patterns. Okay, this example we used last week when we were talking about proportions. So again, this is a proportional relationship because the number of cups of dry rice will serve a certain number of people each time. And that holds true, right, for this recipe or this serving. So nothing changes. So if we know that For 2 cups of rice, it serves 6 people. Let's fill out the value of tables, the table values, and then we'll answer the questions over here. So if I know that 6 people get 2 cups of dry rice, I can break that down to its unit rate, right? The unit rate is right here. That would mean that 1 cup would serve 3 people. Okay, notice that going this direction, the x is being multiplied by 3. Okay, so if I keep doing that, this would be 9. This would be 36. 43 times 3 is 129. And then, oh, look at this. X, that's generalizing. So how can we generalize? No matter what are we doing to the x value to get y? Yeah, we're tripling it, 3 times x. So again, this constant, or this pattern, is times 3 every single time. So, but calculating the constant of proportionality, remember, k equals y divided by x. So k equals 3. Okay. And the equation that represents it, again, we use the form y equals kx. So the equation would be the y value is equivalent to 3 times the x value, all throughout the table. And it's proportional because that will hold true throughout. Let's try this one. This one's slightly different. The number of spring rolls is the x, and the number of people is the y. And you know what? I'm going to go back because I meant to put that on this table too. X and y. So 3 people get 6 spring rolls. So 1 spring roll, let's see, how can we determine that? We can look for patterns here if you're unsure. What times 6 is 3? Ooh, that one's tricky. It's going to be a small number, right? 1 spring roll is half of a person, which sounds weird. But the y value is half of the x value here. And so if I have 1 person, that would be half of a person. 6 people would be 3. Okay, and so on. So always look for patterns to help. You can always ask yourself, what's going on from x to y? And to calculate the constant, we apply that formula. It's just whatever the y value is divided by x gives us the constant. So this one, I'll use the one that was already given to us in the table. The y value is 3, the x value is 6, or 1/2 reduced down. So if I were to, again, apply that constant, because this is a proportional relationship, I can then fill out the rest of the table. So 10 spring rolls would be 5 people, half of 16, 8, half of 25, it's 12.5. And then again, n means we get to just generalize this. No matter what n is, I'll just take half of it and multiply it by the number of spring rolls. The equation would be y equals 1/2 x. Okay, you're walking at a constant rate and your data is shown below in the table. So here's just another example. So 3/2. Again, this is the k. This is the constant of proportionality. Abbreviate there. 3/2, 6/4, 9/6, 12 divided by 8. And all of these, look at them in terms of being mixed numbers. That's the same as 1/2. That's 1 2/4. So we're again 1/2. 1 3/6, or 1/2. See how it's the same? 1 4/8, or 1/2. So the constant, or the unit rate, is 1 and a half. While training for a marathon, Keith kept track of how many calories he was burning on one of his runs. After 2 miles, he burned 234 calories, and at 4 miles, he burned 468 calories. Letter A, is the number of calories proportional to the number of miles? I have to check that. I have to see if the relationship here is the same. So I want to know, is 234 calories per 2 minutes equivalent to 468 calories in 4 miles? Sorry, I think I said 2 minutes. And they are, because 234 doubled is 468 and 2 doubled is 4. I know that they are proportional. So what is the constant? Well, that's like the unit rate. That's like taking the y divided by the x. In this case, the y is the calories. So I'm going to go over here. Let me just do 234 divided by 2. And that is 117. Let me just double check that on my calculator. And you can always use a calculator to help you do your calculations as you check your work and think through things. So that's 117 is the constant. Write an equation to represent the relationship between the miles and the calories burned. Again, y equals kx is the form we use. So the equation is y equals, the constant is 117, because I multiply that by however many miles he went to know how many calories he burned. And then how many calories did he burn after running 7.5 miles? I can use my equation. So what I mean by this is, if I want to know how many calories, that's the unknown, for 7.5 miles, I just plug in 7.5 miles where the x is, and let me figure that out. That would be 877.5 calories burned in that amount of miles. Tables, graphs, equations, oh my. So some of you are wondering, what do these tables look like in graphs? Well, here's an example we looked at last week. T-shirts are sold for $8 each. And so you can see the table. It's proportional because it's multiplying by 8, right? The constant is 8. Throughout, you can check that by dividing y by x and you get 8. And then how it shows up on the graph, just like the unit rate does right there in purple, is where that constant is represented. And basically how we do the graph is we just take each of these rates and we plot them on the graph. So in blue, I'll show you 5 shirts, and if you follow it up, it'd be $40, right? You're taking these values of on the table and just plotting them as like ordered pairs, right? When you studied the coordinate plane. Okay, let's take a look at what's next. Oh, Sahara and her friends are going hiking. She decides to pack 1/3 of a cup of trail mix per person. What could the table look like? Well, let's set up a quick little XY table. X being people, Y being cups of the trail mix. So she decides to pack 1/3 of a cup of trail mix per person. That's the unit rate. So one person gets 1/3 of a cup. If 2 people go, right, she would need 2/3. And we could keep going here. 3 people would be 3/3 or a whole. So that's what a table could look like. Again, we could skip values around as long as we apply this constant of proportionality, because no matter what, each person gets a third of a cup. So what's the constant? The constant equals 1/3, because 1/3 divided by 1, right? I'll just show you using fraction, divided by 1. Change that, 1/3 times 1/1. It's the same thing, right? And then what's the equation that represents this? Y equals 1/3 x. Okay, so before I get to that slide, the constant of proportionality is just a different term that we use in mathematics for the unit rate. So I don't want you to overthink some of this stuff, because you've already worked with the unit rate for a couple of weeks now. That's all it is. And if you really are unsure, then just take a y value and divide it by x, and that gives you the constant. Now, one last thing. If a relationship is not proportional, meaning it has no patterns that stay all the way through, they're not equivalent ratios, if they're not proportional, then it does not have a constant of proportionality. And then here's just a little quick summary slide, and I will let you just kind of read through that on your own. And then, of course, when you use the printout of notes or when you reference this, it'll be here for you. All right. Happy learning.